Open versus closed-loop control. Understanding the trade-offs in control systems. Imagine you're trying to keep a room at the perfect temperature. Do you set the heater to a certain level and forget about it? Or do you keep checking the temperature and adjust the heater as needed? That's the core difference between open and closed-loop control systems. In electrical engineering, control systems help machines and devices behave in predictable ways. They can be simple or complex, but understanding whether they use feedback or not is key. An open-loop control system works without feedback. It takes an input, acts on it, and doesn't check if the output matches the goal. For example, a sprinkler that turns on for a set time regardless of how wet the ground gets. It's quick and easy to set up, but it can miss errors or disturbances. If it rains, the sprinkler still runs, wasting water. Open-loop systems are best when the process is predictable or disturbances are minimal. On the other hand, a closed-loop control system uses feedback. It measures the output, compares it to the desired result, and adjusts accordingly. Think of a thermostat that turns the heater on or off based on the room temperature. If the room gets too cold, it heats more. If it gets too hot, it stops. This feedback loop makes the system more accurate and stable. It can handle disturbances like open windows or changes in outside temperature. But it's more complicated because it needs sensors, controllers, and sometimes more power. Now, what are the main trade-offs? First, accuracy. Closed-loop systems are better at maintaining the right output because they correct errors. Open-loop systems can't do that, so they're less precise. Second, cost and complexity. Open-loop systems are simpler and cheaper to build and maintain. Closed-loop systems requiring extra parts and careful calibration. Third, robustness. Closed-loop systems handle external changes better, making them more reliable in unpredictable environments. Fourth, speed and stability. Open-loop systems can respond faster since they don't wait for feedback, but they risk instability if conditions change suddenly. Closed-loop systems respond more slowly but stay stable because they constantly adjust. Lastly, maintenance. Open-loop systems are easier to keep running because they have fewer parts. Closed-loop systems need regular checks on sensors and controllers to keep working well. In electrical engineering, choosing between open and closed-loop control depends on what you need. For example, controlling a motor's speed in a factory often uses closed-loop control to keep performance steady despite load changes. But for simple devices like a timer or a basic fan, open-loop control works fine and saves money. To sum up, open-loop control is simple and cheap but less accurate and adaptable. Closed-loop control offers precision and stability but comes with added complexity and cost. Knowing these differences helps engineers design better systems for different needs. Whether it's a small gadget or a large industrial machine, understanding these trade-offs makes all the difference in creating effective control systems.